Hello engineers, welcome to JAL Consult. Today we'll be looking at the protective devices used in electrical project installations. Protective devices are devices used in protecting our electrical project from overcurrent, transient surge, related power issues, or electrical users against shock. Overcurrent is when the current flow through a circuit is above what is rated for. It can be an overload, which means excessive demand from the utilization point, or a short circuit, which are faults due to electricity stray outside its pathway. This may be as a result of faulty insulation, loose connection, or fault wiring from the appliance's end, making hot wires to touch the neutral or the grounded system. Transient surge is a sudden increase due to spike in nominal voltage. This do happen when switching on a device or due to lightning effect. The related power issues, on the other hand, may be a reverse phase rotation in a three-phase system. Why electrical users need protection against shock, which can only be ensured by proper grounding. This implies an efficient design must be able to protect against fault, adequate personnel protection, and to be able to minimize disruption. Critical understanding of these devices, their operations, and strategies is thus required because of this position they hold. Based on this, any protective devices to be incorporated in our project must have the following technical characteristics. 1. A rated current value. 2. A short circuit capacity. And the last is the breaking characteristics. The rated current of a protective device to incorporate in a project must be equal to the circuit rating it's protecting or to the short circuit capacity. The breaking value is the peak value of the short circuit current that won't get the device burned. Due to this, protective devices are being rated in standard values such as 6 amperes, 10, 15, etc. Protective devices used in building services industry can be categorized into 4. The first is the overcurrent protective devices. The second is the ground fault protective devices, while the third is the combination protective devices, which is a combination of the overcurrent and the ground fault protective devices. And the last category is the special protective devices. The overcurrent protective devices includes the circuit breakers, fuses, isolators, and the relays. The circuit breakers in this category includes the miniature circuit breakers and the high capacity protection breakers, which we do use for the main feeders, called the molded case circuit breakers. The fuses are also in this category. A fuse simply means a wire which is placed in a fuse holder designed to melt above certain amperage so as to disconnect the supply from the circuit. They can be of a cartridge type or the HRC type. We still have the isolators in this category, which are used as supplement to the circuit breakers. They can only be operated when the current is not flowing through the circuit so as to isolate the system entirely. This implies that they can only be opened after the circuit breakers have been opened and closed before the circuit breakers are closed. The relays, which is the fourth example in this category, are used to evaluate the circuit constantly and trip instantly when the circuit condition changes. They are thus efficient in protecting against transient surge and related power issues. The second type of our classification is the ground fault protective devices. They can be divided into two types. Those for equipment protection, which are called the ground fault protection of equipment (GFPE), and those for the interrupter protection, which are called the ground fault protection of interrupter. The GFPE are used to sense and grant electrical fault at the equipment level. I mean level lesser than the conductor current levels. Their example includes the ELCB, which has been deprecated. The GFPI, on the other hand, are designed to limit electrical shock when the hot and the neutral are in balance. They are thus used to operate up to 5 mA. The combination protective devices includes the RCBO, designed to be a combination of the miniature circuit breaker and the RCCB. The combination protective devices thus protect against overcurrent and earth leakage simultaneously. The special protective devices, on the other hand, includes the ground fault circuit interrupter and the arc fault circuit interrupter. The GFCI prevents bodies that comes in contact with small leakage current, which is usually between 5 mA to 30 mA, at a rate lesser than 30 meter per second. Basically, human body do serves as grounding pair to these electrical leaks and can lead to cardiac arrest. GFCI are thus recommended to be used in bedrooms, kitchen, outdoor areas, or for appliances such as the hand dryers. The FCI basically protects against arcing fault. Arcing fault can be caused by a deteriorated cables. The AFCI are recommended to be incorporated for circuit feeding outlet in building rooms such as the bedroom, closets, etc. As an engineer, proper analysis of projects is thus required so as to be able to select appropriate protective devices for our project. And I will also recommend to be familiar with the NEC principles. Wishing you guys much luck on your projects and a safe design.